for that. Just go to let's go to the executive summary. If I have to do a pitch, basically, right now, in a traditional world, finding a data incident, it's basically painful. It's slow, it's manual. All the sources are fragmented. You have your requirement somewhere, your code somewhere, a lineage in somewhere else. So it takes time, for kind of to figure out, and it takes about 30 to 60 minutes just to triage the incident first. Forget about the fix, just to triage the incident. My fix right now is to get it back to less than 5 minutes and to unify the data sources so that it's easy and so that identify the impact, the blast radius, and the recommended actions. That's essentially what I'm promising, and I hope I'll be able to demo it towards the end. From the problem standpoint, this actually, when I was doing, I actually lead a data engineering and ML engineering platform in my real professional world right now. And I was in a few weeks ago while I was doing this, there was one core data pipeline that actually went wrong. And we were all scrambling around to figure out first, what is the requirement? What exactly was the downstream impact and a lot of things around it. So we had the information, but it's all scattered around. So the important thing was what broke, who impacted, and what to do next. So it's not about we have to figure out what, and the data engineers and then also the downstream people, downstream folks like whether it could be analytical leads or product managers, also wanted to understand if certain pipeline failed, what is their business impact. It could be a machine learning platform which is actually calculating a promo, whatever it could be. So that's fundamentally what the problem was. The problem was the real cost is not the downtime. First, the trust. Basically, now the pipeline is down. Secondly, the time, because we're taking too much time to resolve it. Time in this case sometimes leads to currency. So that's the peak of the problems. And the solution that I'm offering right now is we have, again, as I said, all the fragmented data. We have requirements in the documents. I have a pipeline in the code. I have the lineage in the graph. I would have leaned only to the requirements, but then a lot of time, these requirements actually, the documents actually fall behind. The actual reality is in the code that is actually running on the ground. And there's a lineage, the data lineage, because all this data or the tables that are there is the lineage, is a true representation of how the data is flowing through in my system. So I want to rely on my requirements, the pipeline as a code, and finally the lineage of the graph, the lineage graph of my tables in the data engineering platform. I would like to feed that into a RAG, identify that, and augment that to my context, and then generate the impact brief. That's essentially what I built as a part of this. Let me show a demo on how it is, and then we'll get to the next pieces of it. This is how it looks like. So in this case, I actually gave an error, which is basically a DBT error. If I put in a DBT error and I try to analyze the incident, it tells me in the incident brief right away the downstream impact tables first. These are the tables. The sequence in the document that it analyzed. When the incident has occurred, basically the summary of it. What is the business impact? The business impact is coming from the requirements document. The blast radius, because it has the lineage, exactly where the pipeline goes. If it goes down, what exactly is the blast radius downstream? Whether it's dashboards, whether it's downstream tables, all of it. And the root cause analysis, because it has the actual log itself, the root cause analysis. It also talks about the recommended actions and finally the recovery plan and for the future prevention steps as well. And if we go further down, it also tells me, because I do not want to take the human out of the loop in this. So I wanted to tell what exactly the documents and the SQL that was referred as a part of generating this brief. So it actually points me to those things as well. And finally, the lineage itself. What exactly is the downstream and the upstream? Let's say there's a situation where there is no impact itself. It will tell you the immediate impact is confined to only to the SLA and not to anything else. And that's essentially how I've designed this system. This is a fundamental MVP that I wanted to start with, just to generate the brief, not to do any chat or anything further to it. As a further MVP is what I've designed this, and that's essentially what the demo is. And the technology stack that I used basically is LLM, is the OpenAI's ChatGPT 4o Mini. I've used the quadrant vector store for storing all the my chunks for the documentation of the code, LangSmith for logging and tracing, LangGraph for all the orchestration of this, Fast API for the APIs for exposing the API for the UI that we've just seen, and Raga is essentially for the assessment. At the end of the day, I have assessed this with the different retrievers I'll talk about in a minute. This is a multi-agent architecture. I've created 3 agents. One is a supervisory agent, which routes all the questions. The impact assessor, which will analyze the requirements, the code, and finally the lineage, and finally the writer agent, which actually briefs what exactly was the issue. The data sources that I used was the requirements that I just talked about, the runbooks or the recommendation. It could be Confluence pages, it could be specs, markdown files. I've also feeded in the SQLs, the Pythons, and the YAML configuration files. The lineage wise, I've created a JSON. At work, we use something called open metadata, which will give you a nice JSON format for the entire lineage. I fed that JSON lineage graph. And finally, if let's say there's a Spark error code, I want to look up that error code using Tevily so that I can give a better description so that I have an external API integration. And for chunkings, I've 500 to 600 tokens for documentation and code 400 to 700 tokens. And that's how this is my input essentially for my context. And finally, this is by the system architecture. We have a UI, we have a fast API server, which actually receives all the requests, a long graph orchestrator, which actually retrieves the document from the quadrant store, and the code retriever as well, because I have to retrieve both. And then a simple graph traverser for the lineage itself, and an LLM processor finally to process this request and to reason it. As I said, I've tried out different retrievers because I want to see what exactly gives me better. In case of a code, I would like to use BM25 because it's a code level retriever. In case of lineage, I want a lineage aware retriever. So I tried different retrievers to see how they performed with just a RAG, query expansion, Cohort re-ranking, lineage aware retrieval, and hybrid search. I tried different aspects to it and see which performed better. And these are the different retrieval methods. What I saw at the end of the day here was there's a significant improvement when I used any of these different retrievers, just because the lineage was giving me the better context. The overall best performance was with the lineage aware retriever, with 120% improvement over the regular baseline RAG. So in the demo that you have seen just now, I've implemented that is based out of lineage aware retriever. There is a way that I could actually switch and choose a different retriever, but the implement that I've seen is lineage-based retriever because that's the best performance across all my retriever that I've used. And finally, what I want to see is like eventually, if let's say based on the retrieval that I'm doing, I want to choose, and based on the rating, I want to choose, for example, for code, I want to use BM25. For let's say for the documentation, I want to use semantic chunking, or I want to use some better retriever. I want to choose dynamically based on what the context is for a better context. Right now, I have only 3 sources, so it was pretty straightforward. But I want to improve it with different retrievers and real-time data integration. Right now, it's only 3 sources. I could have had a Slack messaging or something else to be added to make it better. So that's the real-time and rapid improvement that I could do, and eventually to have much more lineage diagram. So right now, the demo doesn't show any lineage diagram. It just lists the sources, but it doesn't show the dependencies among them. I want to have a lineage diagram there. And finally, I want to have a predictive instance. So let's say in the past, I've reviewed something and I've given a brief. I should be able to predictively analyze and say, this incident has occurred in the past. This is what the situation is. So I want to demo something like that. And these are like this now relies on an ML model and much more collaborative response features. So that is what I want to demo for the future. And that's what I want to kind of implement in the future. That's all for the demo. And thank you so much for giving me this time and space.